I'm going to do 4 problems. 1, 2, the same kind, 2. And I'll even graph it to you, give you a little preview of what we're eventually going to do as well. So first equation, there are 2 equations, right? We know what the y value is, so that makes life so much easier. So on the second, so I'll call this, I don't know, equation 1, equation 2. We're going to take that value of negative 7 and substitute in equation 1, so we get 3x minus 5 times negative 7 equals 17. 3x plus 35, because it's a negative and a negative, equals 17. We're going to do minus 35 and minus 35. So 3x equals negative 18, divided by 3, divided by 3, x equals negative 6. So our point, we're literally done. So just to check, and you're going to have to check, we're going to take equation 1, and our point, by the way, of intersection here is negative 6, and we already have the y value is negative 7. So let me check. So that's what that says is that if I take that point and I substitute it in here or here, it makes the equation true. So on the first one, we get 3 times negative 6, because that's my x value, minus 5 times negative 7, because that's my y value. And all that should equal 17. 3 times negative 6 is negative 18. Negative and negative is positive, so it's 35 and 17. And negative 18 plus 35 is 17. So we are good. So let me graph this. Let me take, I'm going to take the first, let me graph equation 2. So let me find y is negative 7 here. And y is negative 7. Well, here's the y-axis, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So y negative 7, guys, is actually this whole line here. So I'm going to, this is why hopefully we'll do this in class. When we get to the graphing, so this is y equals negative 7. That whole line of y equals negative 7. Now I'm going to take the first equation, and I know, and again, this is not part of your homework. Your homework is already done. It's right there, here, right? So for the questions that I assigned you for homework, this is all you have to do. But eventually we'll get this far, and I'm just taking advantage. So I have 3x minus 5 equals 17. I want to change that, okay, to something that looks like this. That's the equation of the line. So how do I take 3x minus 5y equals 17 to look something like that? So, well, let me show you. So 3x minus 5y equals 17. I'm going to add minus 3x to both sides. Sorry, subtract 3x from both sides. So this goes away. And notice that the negative 3x goes to the other side. Right? So I have negative 5y equals negative 3x plus 17, because that was a plus 17, yeah. Still not done, because now I have to divide both sides by negative 5, so I'm going to divide everybody by negative 5. And I'm going to get y, so this is, right, negative 5 and negative 5 becomes y. And I'm going to leave it like that, but a negative 3 and negative 5 is 3/5 x, because that becomes positive, plus, or sorry, that's 17 divided by negative 5, so that's going to be, and I'm going to write it down as a, what do you call it, a mixed number, so that's going to be negative 2 and 2/5. So now it's that's in the format that I want, which is y equals mx plus b, where b is my y-intercept and m is my slope. So if you look at 3/5, it's a positive slope, right? It's a positive number here. So I know that line is a line that goes up like that from left to right. And where is it going to cross on the y-axis? It's going to cross as negative 2 and 2/5. So let's find where negative 2 and 2/5. Negative 2 and 2/5. So here's negative 1, negative 2. Let me change colors. Negative 2 and 2/5 is about here. Okay, I'm not going to be perfect. All right. So if you look at the slope, is 3 over 5. So it's 3 over 5, 3 up, 5 to the right. So from this, the y-intercept, as best as I can, I'm going to go 3 up, 1, 2, 3, and 5 to the right. 1, 2, 3, 4, 5. So here's my second point. If I wanted to do another point, I'm going to go from 3 up, 5 to the right, 1, 2, 3, 1, 2, 3, 4, 5, and this would be another point, and so forth. But remember, with a line, I only need 2 points, right? So if I draw that line, right, so this is my line, y equals, by the way, 2/3 x minus 2 and 2/5. And look, So this is the point of intersection between 2 points. Is that very close to our answer, -6, -7? Well, I mean, obviously I had to like visually, it's not perfect, but does that look like -6, -7? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yeah, look, I'm not that far off. My drawing is not that far off. That point, -6 and -7, is where both of these two lines meet. Line y equals -7 and the line y equals 2/3 x minus 2 and 2/5. So that's what we're looking for visually. But we found that already solving our system. Okay, so all this second part here, and I'll draw a line dividing, it's yet to come. So up today, we did this to left, this whole left side, and then eventually I want you to get to all that and to the right side. Okay. Let me change equations. I take that away, and so the other one, the second one, as an example. So these are not your homework questions, but these are just examples so that you can use to do your homework. Okay. So again, they give us the value, our y value. So again, call this equation 1, equation 2. So I'm going to take that from equation 2, plug it in equation 1. So I get 6x plus 8 times -5 equals -2, 22. We can multiply that, right? So 6x minus 40 equals -22. So those of you who like to do that story, just to see what two inverse operations you're going to do. So here's my variable x, which is currently being multiplied by 6, and then subtract 40. So the two inverse operation I'm going to use, I'm going to add 40 to both sides first, and then I'm going to divide both sides by 6. Those are the steps I'm going to take. So let's follow that. 40 here, 40 here. These goes away. 6x equals, what is that? Positive 18. Divide by 6, divide by 6x equals 3. So my second point, my second coordinate point is 3, 5. So 3, 5 in the graph is 1, 2, 1, 2, 3. 1, 2, 3, 1, 2, 3, 4, 5. So wherever these two lines go, they are gonna meet in that point. So that's what we know right now. So just to double check, let me take equation 1, which is 6x plus 8y equals -22. Let me plug in both of these points, right? The corresponding places. So I get 6 times 3. Y is -5, by the way. Plus 8 times -5 equals -22. Is that true? Yeah, it looks like it. 6 times 3 is 18. 8 times -5, oops. Instead of writing plus -4, I'm just going to write minus 40 equals -22. That equals -2, which is equal to that side. So again, this point right here, 0.35, satisfies this equation and obviously satisfies this equation. In equation 2, if I replace y with -5, I get -5 equals -5. That's what you're doing today. Now, on the graph, let me graph the first line, y equals -5. Y equals -5. Well, -5, first of all, is 1, 2, 3, 4, 5. This is the line y equals -5. So y equals -5. So when you draw this on Friday, you go like this, and you give it a name, right? Y equals -5. Now we got to graph the other one. So the other one's a bit of a pain because it's not in the format y equals mx plus b, right? So we got to switch it. So let's do that now. 6x plus 8y equals -22. Remember, I want to isolate my y, so I'm going to get rid of the 6x. I'm going to do minus 6x, and I'm going to minus 6x on both sides. That goes away, so I'm left with 8y equals minus 6x minus 22. Now I'm going to divide everything by 8. I'm going to get, well, 8 divided by 8 is just y, so finally my y is isolated. On the other side, -6 over 8 is -3 over 4. X, and -22, instead of writing -22 over 8, let's write that as, let's see, we can simplify -22 to 11 over 4, and that's going to be 2 and 3/4 minus 2 and 3/4. And that's my y-intercept. So let's go to my y-intercept. Negative 2 and 3/4 is negative 2.75, and that's about here. Okay, obviously I can't be precise, but it's about there. Okay, and my slope, which is negative 3/4, is negative, so I know that line is going to be a line that goes that direction. So from here, rise over run, right? So instead of, because we're going negative, we're going to go down 3. Instead of up, it's going to be down. 1, 2, 3, and we're going to go 4 to the right. 1, 2, 3, 4. So that's my second point. Right? There's something wrong over here. What am I graphing correctly? Hang on a second. Y equals negative 5. Oh, okay, no, that's fine. But this is incorrect. Sorry. So I have my 2 points. Sorry. And my point intersection is actually 3 and negative 5. I put it on the right quadrant 1. It's 3, 1, 2, 3, 4, 5. This is the point that we found, right? 3, negative 5. So look at my line. It's a little bit off, but if done correctly, and this is my line, y equals negative 3x, negative 3/4 x minus 2 and 3/4. And you can tell that I am still incorrect. What is wrong with this? 3, okay, that's because Mr. Cho can't graph a point. So that is not 3 and negative 5. Jeez. 3 and negative 5 is 1, 2, 1, 2, 3, 1, 2, 3, 4, 5. There's your point of intersection. Jeez, how dumb was that? Okay, all right, my apologies. So our point intersection, we are correct. I just couldn't obviously plot a point. 3 and negative 5. Okay. Ugh, ugly. All right, so those two are the easier ones because y is already super. So let's take another example. Oops. And let me take that, I put over here. So this one is just more work. That's all it is. So now, be sure I had another example. Yeah, guys. So let me take that. X, okay, over here. 3. All right. So not a big deal. It's a little smaller. So y, instead of being a constant, is an expression. Not a big deal. So we have still two equations, equation 1, equation 2. So I'm going to take this. I mean, that's what they say y is. Y is 3x minus 4. So where I see the y in the second equation, I'm going to replace it. So I get 4x plus 3 times, change colors here, 3x minus 4, because that's what I substitute with. And all that equals 1. All right. Look how simple that becomes. So 4x, distributive property, be careful with your signs. 9x minus 12 equals 1. Combine like terms, we get 5x minus 12. Oh God, I can't add. 13x minus 12 equals 1. My variable is x, being multiplied by 13, minus 12. So I'm going to do plus 12 and then divide both sides by 13. So plus 12 on this side, plus 12 on this side. So I get 13x equals 13, and obviously divide both sides by 13, and x equals 1. So that's my first coordinate. I need my y value. So I'm going to take that x value that I just found and pick any equation, 1 or 2. I'm just going to pick 1 because it's easier. And instead of the x, we're going to substitute it with 4. So we get y equals 3 times 1 minus 4. Y equals 3 minus 4, and y equals negative 1. So my second coordinate point is good. So point of intersection is 1, negative 1. So here's where both lines meet. And hopefully I can do a better job this time. Pick any of the two equations. I'm going to substitute, and I'm going to do a little check here. So pick any of the two equations. Equation 1 or 2. I'm going to pick equation 2, because that hasn't been used at all. So wherever I see the x, I put 1, and wherever I see the y, I put negative 1. So I get 4 times 1 plus 3 times negative 1 equals 1, and 4 minus 3, and you see that the right and the left equal each other. Okay, so that works. So let's graph them. The first one I can graph very easily. Y equals 3x minus 4. Y equals 3x minus 4. Negative 4 is my, what do you call, my y-intercept, so 1, 2, 3, 4. My slope is, let me put a 1 here. It's positive, so it's a line that's going to go up. So it's 3 up, 1 to the right. So you can tell 1, 2, 3, and 1 to the right. Right, so yeah, 1, 2, 3, 1 to the right. So my first line, okay, my first equation is this. Hopefully the second one, right, crosses. So the second equation, I have to make a few changes. So it's 4x plus 3y equals 1. So let's isolate y. So let's do minus 4x here, minus 4x on this side. We're going to get 3y equals and minus 4x plus 1. And then we're going to divide both sides by 3, everything by 3. So that finally gets my y isolated, and I get negative 4 over 3, which is fine, x plus 1/3. So for the second equation, the y-intercept is 1/3, so positive 1/3 should be, it's just here. Okay, and it's a negative slope, so the line's going to go this way, and let me just draw that over here. So it's a line that's going to go down. So it's going to go 4 down and 3 to the right. One, 2, 3, 4. 1, 2, 3, 3 to the right. 1, 2, 3, 4, and 3 to the right. 1, 2, 3 to the right. So again, if you I have 3 points. You connect the dots. This is my second equation, negative 4/3 x plus 1/3, and I will use green to show you their point of intersection. So that's where they meet, and that point is 1, negative 1. Okay? What time is it? 9:49. Okay. Yeah. So we have one more. And again, these are just serves you as an example so that you can use these to solve your problems tonight. X, V. Make this a little smaller. Okay, so this one, I like this one because, they tell you what X is. Just a little different. So here's equation 1, equation 2. So I'm going to take what they tell me X is in equation 1 and substitute. So wherever I see X, I'm going to replace it. It's going to be 2 times 3y plus 1, and then plus 4y equals 12. So let me just change colors here. So that's what I replaced. I put 3y plus 1 over here. So now we start to solve in terms of y, which is the same thing. Distributed property, we got 6y plus 1, plus 2, I'm sorry. 6y plus 2 plus 4y equals 12. Combine like terms, 6, that's 10y plus 2 equals 12. Again, here's my variable y. It's being multiplied by 10. Add 2. Inverse operation, so I'm going to use this minus 2 and divide by 10. So follow your story. Let's do minus 2 on both sides. And we get 10y equals 10. Divide both sides by 10. Y equals 1. So if I have my first coordinate point, in this case, I have my y value. I need to find my x value. So take either equation. We'll take equation 1, which is x equals 3y plus 1. And let's substitute the y with 1. We get x equals 3 times 1 plus 1. X equals 3 plus 1, and 3 plus 1 is 4. So my second point. So the point of intersection where these two lines meet is called 4, 1. Let me just do a quick check. So my check, I'm going to pick either equation 1 or 2. And again, I'm just going to pick equation 2. So it's 2x plus 4y equals 12. So if I substitute these two values, 4 and 1, this should make that equation true. So 2 times 4 plus 4 times 1, I replace x with 4 and y with 1. 2 times 4 is 8. 4 plus 1, 4 times 1 is 4. And we get these two. 8 plus 4 is 12. So it proves that this is correct. So we can plug it in that one, or I plug it in the first equation, and you'll see that both of them are true. So let's graph this. So they're both, in this case, a pain because they're not in the format. So I like them when they should be in this. It makes it easier to graph. So let's take the first equation. X equals 3y plus 1. All right. So I'm going to isolate y. So the first thing I'm going to do is I'm going to just switch sides. Okay. Same thing. I'm going to subtract 1 on both sides. So if I will get 3y equals x minus 1. Now I divide everything by 3. And y equals, and here we got x over 3, which is the same thing as 1/3, right? 1/3 x minus 1/3. Okay, so that is a positive slope, so it's a line that's going to go up. And the y-intercept is negative 1/3, which is it's right here. And it goes up 1 and 3 to the right, up 1, 3 to the right, 1, 2, 3. Up 1, 3 to the right, 1, 2, 3. So something like this. So if I were to graph that, or put a line, be a line that goes like that. Okay, again. And we'll call this line y equals 1/3 x minus 1/3. Okay. Second line. So again, the point of intersection that we found, and I'm going to draw that out, is 1, 2, 3, 1, 2, 3, 4, and 1 up. There's a point right here. Point of intersection. Okay. So the other line is 2x plus 4y equals 12. Again, we're going to have to rewrite that in terms of y. So let's do minus 2x over here, minus 2x. So 2x appears from the left, and it appears on the right side, but negative. Now we divide everything by 4, and we get y equals negative 1/2 x plus, and 12 divided by 4 is 3. So the second line, I can use black, okay? The y-intercept is 3, so 1, 2, 3, it's right here. And it's a negative slope, because the slope is negative 1/2, and so it's a line that goes down. So rise over run, 1 over 2, so go 1 down to the right, 1 down to the right, 1 down to the right, and you can tell. So my second line, y equals negative 1/2 x plus 3 is that way, and they meet. So my picture was not too bad. And that's the point of intersection, and that's the solution to both equations. So the point 4, 1 satisfies equation number 1 if you were to plug it in, and satisfies equation number 2. So again, so today all we did was the left side. Eventually, we'll do everything that's on the right side. Okay, so don't worry about too much, but I just wanted to give you a heads up.